Hey, welcome to the Explainer. Today, we're doing something a little different. We're not just going to answer an exam question. Nope. We are going to take it apart, piece by piece, to see how you actually get full marks. We're going to see what the examiner really wants.
So, what's the real difference between a pretty good answer and a full mark answer? Well, a lot of the time, it's just about knowing what the person marking your paper is looking for. It's like learning a secret code. So, let's dive in and crack it.
All right, we're going to deconstruct a GCSE Physics question. Question 3 to be exact. And we're not just guessing here. We're using the official mark scheme to show you exactly what a perfect answer looks like, straight from the people who'll be grading your exam.
Okay, let's start with Part 1, Question 3.1. It's a 2-marker, and it's all about the factors that affect a car's braking distance. Now that sounds pretty straightforward, doesn't it? But to bag both of those marks, you gotta be specific. Let's see what the mark scheme says.
And here they are, the official answers. The mark scheme gives you 5 options, and you only need to give any 2 of them to get the marks. But look how specific they are. It's not enough to just say bad weather. You've got to say wet or icy road conditions. And it's not just worn-out parts. It's poor condition of brakes or poor condition of tires. That detail, that is what gets you the points.
Now check this out. This is a little note right from the examiner's guide. It says they'll allow weight for mass. Now, any physics student knows weight and mass are technically different things, right? But this little note gives us a peek behind the curtain. It shows the examiners have a bit of wiggle room, and that's super useful to know.
All right, let's move on to the next part, which is all about reaction time. Again, it's about being really precise. In this question, you're given some data, and you have to draw 2 conclusions from it. Let's see what they're looking for.
So, what are the 2 conclusions the mark scheme wants? Well, here they are. First, that the mean reaction time goes up after drinking alcohol. And second, that this change isn't the same for everybody. You see, one point is about the overall average, and the other is about how the data varies from person to person.
And this is so important. Notice the difference in the wording, mean versus all people. Just writing reaction time increases isn't going to cut it for that first mark. You have to use the word mean. For the second mark, you have to point out the difference between people. It's all about showing you can interpret data with precision.
Okay, on to the calculation. This is question 3.4, and it's worth 4 marks. That means 4 chances to score points. And the absolute #1 rule for any calculation question, you guessed it, show you're working.
So the mark scheme breaks this down beautifully. Step 1, substitution. Just plugging the numbers into the right places gets you a mark. So 1500 equals 20 times t. Boom, 1 mark. Step 2, rearrangement. Shuffling the equation around to get t equals 1500 divided by 20. That's your second mark. And finally, step 3 is the correct final answer. 75, and don't forget the units, s for seconds. It's a simple step-by-step process. And this right here is exactly why you always show your work. Seriously, even if you completely flub the final calculation, you can still pick up those earlier marks for substitution and rearrangement. Never, ever leave a calculation question blank. There are easy marks to be had. All right, we're on the home stretch. The final part of question 3 deals with something that trips up a ton of students, the difference between speed and velocity. It's a 3-marker, so it's definitely worth taking a moment to get this right. So how do you get these marks? Well, the first point is all about the definitions. You need to state clearly that velocity is a vector quantity, which means it includes direction. Speed, on the other hand, is a scalar quantity, which means it doesn't. That's the fundamental difference. Okay, so that's the definition, but to get the rest of the marks, you have to apply it to the scenario in the question. The mark scheme is looking for this key idea. If the road isn't straight, the car's direction is changing. And if the direction is changing, then the velocity must be changing too, even if the speedo stays at a constant 30 miles per hour. And here's another one of those awesome little examiner's notes. It says you can also get the mark for saying the driver may change lanes. Why? Because changing lanes is another way to describe a change in direction. It shows you're thinking about the concept in a practical way, and they'll reward you for it. So what's the big takeaway from all this? What have we learned from thinking like an examiner? Well, it turns out there are some pretty clear strategies you can use to squeeze every last mark out of a question. Let's quickly recap them. Okay, here are the golden rules. First, be precise. Use the right scientific terms, like mean or vector. Second, for any calculation, show all you're working, always. Third, make sure you know your core definitions inside and out. And fourth, don't just state the definition, apply it to the specific situation in the question. And remember, sometimes there's more than one right way to say something. It's not just about what you know, it's about how you communicate it.
Now that you've got this insight, now that you can kind of think like an examiner, which question are you going to tackle next? Because by really understanding the mark scheme, you've just unlocked a much smarter way to revise. So that's it for this explainer. Go get 'em.